Hi, my name is Mogg.
And I'm Rhys Craggs.
And I'm Jayson Gaunt.
We're here today to produce a video that will provide information about vehicle emission controls and standards. On a motor vehicle, there are a few areas that release emissions, and they include through the exhaust and through fuel evaporation. There are many types of emissions that are put through the exhaust, including volatile organic compounds, nitrogen oxide, carbon monoxide, and particulate matter. Petrol consists of hydrocarbons, for example C8 and H18. The complete combustion process produces fully oxidized carbon and hydrogen, CO2 and H2O. Exhaust emissions are associated with respiratory problems such as coughs, bronchitis, asthma, and in severe cases problems during pregnancy and even death. In the case that you find a person that has gas poisoning, you must follow the following safety instructions. Firstly, call for emergency help and open the area any way you can. If possible, rescue the victim, but if it's too dangerous, do not attempt it. You don't need to be the second victim. If rescued, then check the person's airways, if they are breathing and if there's a pulse. If necessary, attempt CPR. Continue monitoring the person until help arrives. We sourced a 10-second rule from the following website and found that the public can report a vehicle if it is found to have been smoking longer than 10 seconds after startup. Information on the reports can be found on this website.
How does catalytic converter work? The catalytic converter was designed to deal with harmful pollution such as gases produced in the combustion chamber. The catalytic converter turns gases such as carbon monoxide, hydrocarbons, nitrogen oxide into non-toxic emissions such as gas dioxide and water vapour. The toxic gases pass over the cat converter's chemical-coated ceramic honeycomb and results in a non-harmful gas. It will only operate properly at operating temps. What destroys the catalytic converter? By using leaded fuel, it coats the catalytic converter in lead, making the chemicals in the converter fail. Overheating will also damage the converter. When conducting a scan on a car, these are some of the things to look for. Ensure the scan tool is up to date and has the correct equipment, that the CO sensors are operating correctly, which can be checked by the scan tool. The conditions of the exhaust are good, in good condition, no leaks. Checking the catalytic converter with the scan tool and that the EGR is operating properly. When setting up a coder machine, this is a few little things to getting started. On the side, switch to turn the computer on. These are the canisters which hold water while the car is running, need to be empty before operating. And this probe here needs to be in the exhaust, which also contains another water canister. Once the computer is fully loaded, simply go into the coder engine analyst system. Here it shows all your settings. By starting the tests on all the settings, you simply go to the top corner where it says start, press start, and wait for them all to go through and test all the settings. Once the test is complete, simply by pressing next, you can start the start test on the vehicle, which will go through idle test, snap test, cruise test, D-cell test, free-cell sampling. For the test that we want to do, we'll be using the gas page. This graph here shows us what is happening with the CO carbon dioxide coming out of the exhaust. By adjusting this screw here, we can adjust the air-fuel flow mixture. This graph here tells us whether the mixture will be lean or rich. Now that I've adjusted, the mixture of the air-fuel has gone very lean. I will now change it to rich and the pattern will change. I have now made the airflow mixture really rich. Note the change in the graph. For any emission laws on any Australian vehicle, they can simply be found under the bonnet. Here they will tell you the spark plug gap, the idle RPM and the ignition timings.
To meet with today's emission control regulations, manufacturers have designed many various types of devices to reduce motor vehicle pollution. We'll start with a few that are used on many of today's vehicles. The exhaust gas recirculation, or EGR. Here is a good example of an electronically controlled EGR system. Note the steel pipe attached to the exhaust manifold, which is attached to the EGR valve, which is then attached to the intake system. Its purpose is to add exhaust gas to the intake so that it mixes with the air-fuel charge and enters the cylinders. The exhaust gas, being cooler than combustion temperature, will absorb some of the heat when combustion occurs. This will then reduce the temperature of the gas being expelled, resulting in lower NOx emissions entering the atmosphere. The systems like the PCV and the fuel evaporative system use the aspect of ventilation to recirculate vapours back into the engine to be burnt under normal conditions so they don't enter the atmosphere causing pollution. Another way to control engine emission output is to prevent the engine from running too rich or too lean by using oxygen sensors.
An O2 sensor measures the amount of oxygen in the exhaust and sends a signal to the ECU. This will then adjust fuel injector operation to allow more or less fuel be burnt. This is a continuous process, so the optimum air-fuel ratio is always obtained. This system uses a self-diagnosis in the ECU that will record and store information in the ECU memory. This can be checked by using the correct diagnostic equipment.